So I'm recording to the cloud. So we're starting just talking about the skeleton right now. It's going to last for two full chapters. Let me go to my first whiteboard and just write a few notes down. We divide the entire skeleton into two sections, two main sections, and those are what we call the axial skeleton and the appendicular. This week, chapter 7 is it's all concerned with this one, the axial skeleton. That word is derived from the word axis. So just think of the midline of the body. Most bones on the direct midline of the body are associated with the axial skeleton. So this would include the skull, the vertebral column, all of the vertebrae, and the vertebral column includes the sacrum and the coccyx, the tailbone. Also includes the sternum, the breastbone called the sternum, the thoracic cage, which you and I refer to as the rib cage. That's the axial skeleton. The appendicular skeleton is basically everything else that's not included in the axial skeleton. The axial skeleton, I think, has 80 bones. The appendicular skeleton, 126. There's 206 bones in the human body. We're going to talk about this one today. So let's get on with it without wasting any time. I'm just going to go to the skull, which is today's major topic. We all know where the skull is, what it looks like in some form or fashion. We'll get into more detail than that. The skull can be divided into two major areas or groups of bones, and that is the cranium. And think of the cranium as the top of the head. So the cranium pretty much is where your hair grows on your head and your forehead as well. And we sometimes call the bones that make up the cranium cranial plates. So if you hear me say the word plates, I'm referring to the bones, the flat bones that make up the majority of the cranium. The skull then is also comprised of facial bones. And just like the name of the category implies, it's bones that make up the face, the structure of the face. So the cranium, we'll start there. It largely, we say it creates what's called a cranial vault, V-A-U-L-T. That means a space that encloses predominantly the central nervous system, the brain, and some of the brainstem as well. And it's made up of 8 specific bones, talking about just the cranium, not the whole skull. The 8 bones of the cranium are, I'll list them and then we'll talk about them in detail. The frontal bone, which is basically the forehead and the top, past your hairline. So the frontal bone, there are 2 parietal bones. Those are left and right. Those make up the majority of the top of the cranium and also the majority of the sides of the head of the skull. There's 2 parietals. There are 2 temporal bones, which are the inferior lateral sides. So down by your ears, we find temporal bones, and an occipital bone, which makes up the rear, the posterior backside of your skull, and sort of underneath, cradling underneath the floor of your skull. And so that's 2, 4, 6. There is a sphenoid bone. It's pronounced sphenoid as if it would be spelled SF. That is very difficult to see in an articulated skull from the outside. And also the ethmoid, ETH. So those 8 bones make up the cranium. Sorry. It's allergies this time of year when the leaves fall and the mold comes off the leaves. I get allergic reactions. So sorry about the voice today. So those make up the 8 bones of the cranium that create that cranial vault that house the brain. The floor of that vault, I'm just going to draw a quick picture over here. If we were to take a saw and cut off the top of my head right now, and you pop the top of my head off, and we're looking down in my head, it would be shaped something like this, with my nose, my eyes being here and my nose here. So you're looking down inside of my head if you could pop the lid off of the skull. There are what we call the cranial and facial divisions of the skull, as well as the cranial fossa, F-O-S-S-A. Fossa just means like a depression, a cavity that's created from a depression. And the inside of our skulls looks something like this. This isn't perfect, but it'll give you an idea sort of what we're looking at. And there's a structure right in the middle here. I'll talk about that later. This area is a shallow plate, and it's called the anterior cranial fossa because it's toward the front of the head. This area in here that I'm circling now is called the middle cranial fossa, and it's deeper than the anterior cranial fossa. And the posterior cranial fossa is more variegated. It's deep in this area and a little bit more shallow in these wing areas that I've drawn right here. So it's very convoluted inside of there, and it secures central nervous system tissue, the brain. So let's start with these cranial bones one by one. And we'll start here. I'm going to go to a new page now and just write frontal bone. Whenever you see frontal bone, think forehead, because that's the most obvious part of the frontal bone. It does go up to the top side of our head though as well. So if I draw a skull in profile, the frontal bone, the superior end of the eye sockets, the orbits up here, includes part of the frontal bone, and it sort of drifts up to here, all of this area, and I'll give it a color. So it goes past the typical hairline, but it makes up the visible part of this to the eyes right here on the forehead. That's all frontal bone, and the anterior lateral sides of the head as well, very lateral sides. So the frontal bone, we call this front part that I put an arrow at squama, or the squamous portion. Squama, or I'm going to put in parentheses squamous, that means flat. It's talking about the shape. In this area, the bone is sort of layered and scale-like on that squama region of the head, of the forehead. The thickening, which I didn't draw very well in my cartoon, the thickening as the frontal bone comes forward, you know we have a brow, a bony brow right here that our eyebrows sit on. That's also part of the frontal bone, and it's referred to as the supraorbital margin. That just, supra means above, orbital means eye socket, and margin just means this demarcation, this line that I've drawn that's created by that thickening of bone. There's also, within this margin, so I'm going to draw it a little bit larger, within that thickening of that brow, that supraorbital margin, there's also something, a foramen that's created, a foramen, which means hole. If you've done some of your exercises, a foramen is just a hole through bone. Typically, nerves and vessels pass through foramen. The word foramina is just Latin for very small hole. Sorry, let me spell that correctly. That's an I. Foramina just means even a smaller hole. So when I list something as a foramen or foramina, just think it's a hole, and there are supraorbital foramina or foramen right here that nerves and vessels pass through that bone tissue. And finally, on the frontal bone, this term, the glabella, this refers to the flat portion of our frontal bone that is just above and right between our eyes. It's right on the midline. So if you take your finger right now and you press between your eyes, above the bridge of your nose, there's a flat portion. You can actually feel what was once a suture there, a seam on the glabella. So the next bone, a cranial bone that we're going to talk about on our list, are the parietal bones. There's a left and a right parietal bone. They are on they make up most of the roof of the head and some of the lateral and posterior side of the head. So I'm going to sort of give you an idea. Parietal bones, left and right, would be here. Frontal bone was originally two bones at one time, but it fuses very early on. The parietal bones don't fully fuse until after birth. You're looking right now at the right parietal bone. There's another one on the left side, and they come together at a suture right on the midline of the head, all along here, if you were to look at the top of the head. So the parietal bones define the four major sutures of the skull. So underneath parietal bones, I'm going to write sutures. A suture is a type of joint. It's an immovable joint. We always think of joints being movable. Not all joints are movable. A suture is an example of an immovable joint. They typically tend to be interlocking joints, like this, almost like a zigzag pattern. And that helps keep them stable. So there are sutures. There's one here. There are major sutures. There's sutures all over the skull, some so minor that you can barely see them, and they're not worth memorizing or mentioning in this conversation. But the four major sutures are worth mentioning, and I do want you to know those. And they are created by the articulation points of the parietal bones. That's why I'm listing the four major sutures under parietal bones. And those sutures go like this. The frontal suture is the immovable joint that I've drawn. I'll extra highlight it now, between the frontal and the two parietals on both sides. So the frontal suture, it's also called the coronal suture. If you read that, it's the same thing. This is the immovable joint between the frontal bone and, I'm just going to put left and right parietals, parietal bones. The second suture that I'm going to list is called the sagittal suture. S-A-G-I-T-T-A-L. This is between the left and right parietal bones. So if you had a bird's eye view of the head, you're looking directly down on top of the skull, like this. The frontal or coronal suture you would see going across right about here. Again, there are the nasal bones. The sagittal suture does this. It runs right on the midline of the body of the head. It comes back here. And I'll highlight it in green. It's this suture between the left and right parietal bones. Third suture is called the lamb, L-A-M-B, like a baby lamb, lambdoid, D-O-I-D. The lambdoid suture, I'll put in red, is this one back here. that is the joint, the immovable joint between the two parietals and the occipital bone back here, which I haven't talked about yet. And finally, number 4 are the squamous sutures. And there's 2 of these. So I'm going to put left and right. If we go back to the side, I'm going to go back to my skull cartoon at the top of the page, and I'll use blue. The squamous suture, let me tell you what it is first, is between, I forgot to write lambdoid and squamous. The squamous is between the temporal bones and parietals. I'm running out of space down there, that's why my P is cutting off. That's supposed to be a P. And the lambdoid, let me write that, that's between the parietals, left and right parietals, and the occipitals. The occipital bone, it's a single bone. Those are the 4 major sutures in the human body. And there's 2 of these. There's 2 squamous sutures, and those ride in this arc in red that I'm drawing. So the temporal bone is here, and the parietal and frontal make a connection with that squamous suture on either side of the head. So those are the major sutures, and the reason we list them under the parietal bones is because the parietals have a immovable joint with all 4 of these. They create all 4 of these sutures. If I have time at the end of this, if not, I'll probably start with this next time. Something called a fontanelle. This is appropriate to talk about when we're talking about sutures. A fontanelle is a infant's, a newborn's soft spot on the head. That's created by unfused cranial plates. So all of these sutures are not fully fused at birth. Technically what a fontanelle is, it's not a soft spot, it's connective tissue. It's a massive connective tissue between those cranial plates, but it's not bone fused to bone. That's why it feels soft in that area of an infant's head. And that can accommodate the child's head squeezing through the birth canal at birth, as well as it allows for growth of the bones and the central nervous tissue underneath it rapidly. Those sutures generally start to fuse at different times within the first year of life. This section back here on a baby's head between the posterior side of the sagittal and the lambdoid tends to stay open longer than the other fontanelles. All right, let's move on. So we've done parietals. I'm going to see if there's anything else. Let's go to the occipital bone. The occipital bone creates the rear posterior backside of the head and cradles underneath. So if I do my skull again really quickly, there's a nasal bone. Skull comes down here. The occipital bone does this. It rides in this area, color it in yellow. So it creates the lower backside, the inferior backside of the head, as well as the sort of the floor of the skull, where particularly where central nervous system tissue exits the body for the spinal cord. Now the occipital bone, I'm going to give you some features or markings on this bone that I'd like you to know. It creates something called the posterior cranial fossa. Fossa just means depression. Think of it as a crater. And this posterior cranial fossa houses and protects the cerebellum of the brain. It accommodates for the space of the cerebellum. We'll talk about these brain structures when we do the nervous system. Cerebellum in Latin means mini cerebrum, and that hangs down right in this area from the cerebral hemispheres. There's also a major marking called the foramen or foramen magnum. Foramen means whole, magnum means big. The largest foramen, I'll say that this word's two different ways, foramen and foramen. When I was a student, my instructor said foramen, so that's what's sort of tattooed on my brain, but I believe that technically the correct pronunciation is foramen. That on the floor of this occipital bone is a really large hole like this, where the lowest structure of the brain stem meets the spinal cord and penetrates through this hole like this. So if you were to look at the underside of a skull, you would one of the first things you would notice is this giant hole for the spinal cord to emanate from the skull. On either side of this hole, so let me do now you're going to look at the underside of the skull. If we have not a bird's eye view, but a worm's view from the ground up, would look something like this. If this is the teeth of the hard palate, in here, cheekbones, and this zygomatic arch comes out on both sides, and then the cranium. The foramen magnum is located right about here. I'll color it in so it looks like it's a hole. On either side of that foramen magnum are two bumps, significant bumps, here and here. They're raised, smooth bumps called condyles, and that's what the word condyle means. It's a smooth bump that articulates with another bone. So I'm going to write these, the occipital condyles on either side of the foramen magnum. These bumps, if we looked at them from this underside view over here, they would hang down a little bit like this on either side of this hole. And they sit, those condyles, they rest in the first cervical vertebrae, C1. I'm just going to write they rest in cervical vertebrae 1. And they ride back and forth like this. And they allow us to nod our heads, yes. So when you nod your head, you put your chin down and then raise your eyes up to the ceiling. These occipital condyles are riding in grooves on the first cervical vertebrae. I'm still talking about the occipital bone. The hypoglossal canal, that means a passageway through a bone. These are tiny and they're hidden just above the condyles, right about here. So these hypoglossal canals allow a cranial nerve to pass through, and it's cranial nerve number 7. There are 12 cranial nerves that we will learn when we study the brain. And they just have Roman numerals associated with them. So let me write that now. Cranial nerve number 7 passes through this hypoglossal canal. Finally, on the lower side in this view here, there's a large bump. It's called a protuberance. If you feel the back of your head on your occipital bone right now, I have a pretty prominent one. You may feel what feels like a bump sticking out here. It's actually on the underside of the occipital bone where I drew it the first time. That is called the external occipital protuberance. And that is a connection point That as well as the crest, the external occipital crest, which is a line of bone. Sometimes it's called the nuchal crest. It extends this way. I'm going to put and crest. These are anchoring points for a very important ligament. They anchor something called the ligamentum nuchae, Nuchae. That is a long, tough, fibrous ligament that runs from that place on the back of your head that you just felt all the way down your cervical vertebrae to C7. So all the way down the back of your neck, like this thick, tough, fibrous band of dense connective tissue. And that helps us, it supports the head. It enables us to hold our head up so it doesn't flop around. Now let's go on to the temporal bones. And just to remind you, before I go to the next page, the temporal bones are located down here and they are kind of arced on top. I'll color the temporal bone in right now in blue. There's one on the right, one on the left. It's almost where, just about where your ear is located and some bony areas around that. But this temporal bone also goes to the floor of the skull, underneath the skull here. So let's go to another page. I'm going to write temporal bones because we have one on either side of the head, left and right. The squamous part of this bone is just, squamous means flat. So I'll write that again in case I ask you on a quiz. The squamous portion of the frontal bone as well as the temporal bone just means the broad, flat region. And the bone grows in layers, like scale-like layers in those squamous areas. The temporal bone has a feature called the zygomatic process, which on one of my previous diagrams, this one, from looking from the underneath, this bridge of bone that comes out, it's formed partly by our cheekbones in front here, and the blue part is the temporal bone part. So if we were looking at a temporal bone section, here's the flat portion of the temporal bone on the sides of the head, and then there's this bridge-like structure sticking out here called the zygomatic process. It doesn't make this entire bridge, so I'm going to color part of it in red and part of it in blue. It's too difficult for me to draw it on this side view up here, but there's a protrusion that comes towards you as I'm drawing it this way, that comes out of the temporal bone called the zygomatic process. So let's go back to this page. It creates part of the zygomatic arch, with the zygomatic bone, which are our cheekbones. I know the language is confusing because they use it, but that's as good as you need to know for this level of class. Also within the temporal bone is something called the mandibular fossa. Remember, fossa means crater or cavity, so it's a depression on the underside of the temporal bone, right in front of your ear hole. On the underside of your temporal bone is a depression. So I'm drawing bone. It's a upside down crater or cavity. It's a space for the mandibular condyles to articulate with the temporal bone. So your lower jaw, the mandible, has these two prominent projections called condyles that stick up. I'm going to draw the lower jaw now from side view. And these condyles stick up in this space to create this hinge joint. And it actually comes up. There's another. So there's the lower jaw. the teeth, we're talking about this area right here. The mandibular fossa is the crater on the temporal bone. The mandibular condyle is actually this pin on the mandible itself. That creates what we call the TMJ, the temporomandibular joint. The tympanic part of the temporal bone refers to where the hearing mechanism is located. So tympanic section or part of the temporal bone is where the hearing anatomy, I'm going to write the hearing mechanism. Hearing mechanism is located buried in the floor of the temporal bone. So we have a middle ear in there, which is an air-filled chamber where the three small, on each side, where the three smallest bones in the human body are located. They're called ossicles. And then there's another portion. When we get to special senses, I'll draw it and explain it to you. There's another portion called the inner ear mechanism. That's actually where vibrations get converted to neural impulses. But that whole hearing mechanism is located in the floor of the temporal bone. The ear hole, which would be located right about here, is called the external auditory or acoustic. I think Marie calls it acoustic. The external acoustic meatus. Meatus is like a foramen. It's a hole, but it's not really a hole that goes all the way through a bone. It's an invagination or a canal that's created in the bone itself. The external acoustic meatus is in the temporal bone, and it's, just think of it as the ear hole. It's where sound waves get guided inward so that they get converted to vibrations so that we can hear. Still talking about temporal for just another minute. The squamous part is the flat part on the sides of the head. The petrous part houses this hearing mechanism. It's thick and bulgy on the floor of the temporal bone. It's hard to explain without you holding it in your hands, I get it. A couple other bone markings within the temporal bone. I'll go to another page so that I don't make a mess. So I'm still talking about the temporals. There is the jugular foramen. Remember, foramen or foramen means a hole. So this is a hole through the bone that our jugular veins travel through. Actually, our internal jugular veins drain blood from the head back to the heart. So I know that some of you know this, some of you may not. Whenever you hear me say or you read artery, we say arteries supply. They feed areas because they're taking nutrition and oxygen to an area of the body. Veins, we say drain an area because they're taking blood away from an area back toward the heart. So the jugular foramen are holes for the internal jugular veins to drain blood from the head back down toward the heart. Also the carotid, your book calls them carotid canals. They're foramen. I'll write it like your book does, and then in parentheses I'm going to write foramen. This is where the carotid arteries penetrate up through the skull, through the temporal bone, to feed blood to the head. The carotids come off of the aortic arch, and they head in a superior direction, and they divide into internal and external. The internals feed the inside of, most of the inside of the skull. The externals feed the outer portion of the skin and the outer portions of the face. Foramen, which means hole, the foramen lacerum are also located in the floor of the temporal bones. Foramen lacerum, they're not perfect circular holes. The jugulars sort of look kidney bean shaped like this. The carotids are perfect circles, and the foramen lacerum tend to look like this. And in life, there's a pair of them. And there's a pair of each of these. And I've drawn them in opposite direction. I should have done that. If this is the foramen magnum down here, we're looking at the underside of the skull. Here's the big hole of foramen magnum. Jugulars are located here, carotids on top. The foramen lacerum are going toward the front, toward the face, but we're on the bottom of the skull now. Those lacerum in real life have a thin connective tissue over them, so it's usually not a broad open hole unless you're looking at a skull from somebody who's deceased or disarticulated from the body. These two are worth mentioning. These markings, the mastoid process. I told you the temporals are just packed full of these really minute processes. The mastoid process, you can feel that your mastoid process right behind your ear. There's a bulge or bump. If you feel your skull right there, that's your mastoid process. It hangs down. There's my skull. If this is the floor of the temporal bone right here, it hangs down like this, almost like a finger. It's like the size of your little finger, and it hangs down. And it is a place for attachment of tendons for muscles in the neck. So I'm just going to write anchors, neck muscles. And just medial to that, so even for, if this is the mastoid process, even going further toward the middle underneath is a pointier process like this called the styloid process. It's really sharp and pointy. When I was young, I'm older than everybody in this class. When I was young, we listened to music on vinyl. And the needle that you put down on a vinyl record is called a styloid or a stylus. That's how I always remembered this, because it looks like a record player needle. Anyway, this anchors neck and muscles of the tongue. All of these are located within the temporal bones. There's a foramen sort of between these two processes, and it's called the stylomastoid foramen based on its location between here and here. Remember, foramen or foramen means hole, and you guessed it, it's going to have nerves and or vessels going through it. This one in particular allows cranial nerve number 7 to go through. That's actually a facial nerve that innervates a lot of the side of the face. Let's move on now to the sphenoid bone. I'll describe it, I'll draw it as best I can. It's almost impossible to see very well from the outside of the human skull. Sphenoid bone, first and foremost, is called the keystone of the cranium. The reason it's called the keystone of the cranium is because all other cranial bones articulate with this bone. It's in the center of the skull, and all the cranial bones that we've mentioned so far articulate with the sphenoid. It's butterfly-shaped or bat-shaped, particularly when you look at it from the top. So I'll just write that. It actually has greater and lesser wings. If you look at a diagram in your book, you'll get a better sense of what those wings are. Let me go on. I'm still going to keep on the sphenoid here. I'm just moving on to a new page so I can perhaps draw you a picture. The top of this bone in the skull, let's quickly draw the outline of the human skull. I'm going to use red because your book always uses like a hot pink color to designate the sphenoid bone. It sits in the front middle of the skull, the floor of the skull. So we've popped the lid off the top. Let's say you took the top of my skull off and then removed my brain. So this is looking down at the floor of the cranium. And the sphenoid from the top sort of takes this shape. Like so. And it has these wings that are associated called the lesser and greater wings. This is just a ridge of bone that sits closer to your point of view. It sits on top, like hangs out over the rest of it, like so. Everything in red is part of the sphenoid. The part that I just colored in solid is called the lesser wing because it's smaller, even though it sits almost on top of the greater wing. So here's the greater wing, and this is called the lesser wing. It sits on top of the greater wing. Right in the middle of this bone, right in this area here, is a special marking or cavity that I'm going to highlight. It's called the sella turcica. It's pronounced turcica, Turcica. That produces almost like this horse saddle shape. So from the top, it kind of looks just rectangular like this. The area that I actually drew here is more rectangular in person. And there are ridges here and here. So if you look at this from a lateral view, a side view, it would look something like this. And you can, and this front portion is actually a little higher. You can stick your little finger, that's about how big this space is, right down, the tip of your little finger fits right into this little cavity that's created by the sella turcica. This whole structure is called the sella turcica. The cavity, the fossa, is called the hypophyseal fossa. I'll tell you why as soon as I write this. And we say the hypophyseal fossa of the sella turcica is a place that cradles and protects the pituitary gland in the brain. So the pituitary gland hangs down from the underside of the brain. Let me quickly draw a brain here. There's the cerebellum under here. And right about in this area, the pituitary hangs down. I've exaggerated it on this stalk like this. And the hypophyseal fossa of this bone is a place to protect that pituitary gland. Hypophysis is a scientific name for pituitary. That's where it gets its name. If we take this bone out of the skull, this is hard to do. Conceptually, it's a bit challenging, but we've looked at a top version here, a top view, bird's eye view. If we look at it from the front or back, this bone, this is kind of what it looks like. This isn't perfect. It's very variegated. I know that sounds confusing, but there are all these crevices and cavities. It's a very delicate bone as well. This is a front, or actually, I think I'm drawing a back view now, posterior view. There are these troughs of bone tissue that hang down like this on either side. In this area, there's a cavity or a trough, sort of like a gutter coming down the side of your house. These legs, kind of, these legs sticking down from the bottom of the sphenoid bone are called the pterygoid process with it's PT. The reason I'm drawing this is so that you have some sort of reference as to what I'm writing and talking about. So we're in this bone. These are two pieces of bone that hang down. The word process means something that sticks outward, jutting outward from a bone. And they project downward or in an inferior direction, and they anchor, this is where it gets its name, they anchor the pterygoid muscles. Which allow us to chew our food. Really control the process of chewing. Also within the sphenoid, before I leave this page, there are optic canals running through, with optic nerves running through them. There's also, this bone helps create the superior optical fissure or orbital. Orbital's more proper. A fissure is just a crack or a crevice through a bone. When we look in the eye sockets from a frontal view of a skull, I'll try to draw that for you really quickly. If you were to look in, if this is an eye socket, an orbit, here's the nasal bone, and then here's another eye socket or orbit. If you look inside there, there are these cracks or crevices in the bone tissue called orbital fissures. And it's for all sorts of things to pass through the bone tissue. The sphenoid bone helps create these two top parts, the two top wings of this. It's like a letter X. And the sphenoid bone helps create these two fissures on top, right here. And that allows all sorts of things to run through nerves and blood vessels, particularly optic nervous tissue. Last thing on the sphenoid, I promise, and then we'll get off of this, is something called the foramen or foramen rotundum and foramen ovale. And these are just holes in the floor of the sphenoid bone that allow for cranial nerve number 5 to pass through. Cranial nerve number 5 is called the trigeminal nerve, which innervates a lot of facial areas. Okay, let's go on to ethmoid. This will speed up, I promise. We'll cruise through some of these bones, and because there's hardly any markings on them at all. The ethmoid is also in the center of the cranium. We can't see it hardly at all from the outside of the skull. It's roughly the size of a golf ball, although it's not perfectly round. It kind of looks like a honeycomb shape. It has this point up top, and the bone itself is shaped something like this. And it has all of these variegated ridges in it to increase surface area. And that's roughly life-size. Well, I don't know on your board. If you're on a phone, obviously it's not life-size. On my iPad, I've drawn it just smaller than a golf ball, which is about life-size. So the ethmoid bone has horizontal areas in it where my squiggles are called the cribriform plates. So these are markings within the ethmoid bone itself. These plates are just flat, horizontal flat little plates of bone that have small holes in them called the cribriform foramina. That just means small hole. These are important. The cribriform foramina are tiny, tiny holes that allow, let me close the door here, that allow olfactory nerve endings to penetrate. So our sense of smell, our olfactory nerves are basically just endings that are stimulated by changes of chemistry in the environment. And then when they're stimulated, they send signals to the brain, and our brain interprets what it is we're smelling, something good, something foul, something smoke, whatever. But those nerve endings penetrate all throughout this area, the cribriform plates, and they're just basically coiled nerve endings like this, that when changes in the environment, in the atmosphere, the chemistry changes, they're stimulated to fire an electrical impulse. Just a couple more features of the ethmoid. The crista galli, it's two L's, is the top of this sharp ridge here is called the crista galli, and it's a process or a protrusion of bone that anchors the dura mater, which is the outer covering, fibrous connective tissue covering on the outside of the brain, and it also secures connective tissue from the falls cerebri. Don't worry about it. Just recognize that the crista galli anchors this. You don't have to worry about what this is yet. It's connective tissue that runs down the division of the left and right cerebral hemispheres. And finally, last thing about the ethmoid, it contains, the bone tissue contains ethmoid air cells. And the word cells here is not referring to cells like human cells in tissue, like an individual cell. This is referring to air pockets or air cavities, like a jail cell. We use the term jail cell to describe a space, not necessarily a biological cell. Within the ethmoid bone are also the superior and middle nasal concha, C-O-N-C-H-A-E. Nasal concha they're bone in structure, but they have fleshy tissue covering the bone. Inside of our nasal cavity, we have, from a frontal view, if you were to look inside the nasal cavity, if this is the bridge of the nose, the nasal bone's here, there's a hole here, and we're going to look inside of it. Here's the septum. Along the internal part of the septum are these ridges of bone like this, these three flaps of bone here. The superior would be the top one, middle is here. They're like Roman blinds or Roman shades that cover a window that come down and they flap over each other like this. There's a superior, middle, and inferior. The ethmoid bone creates the superior and middle flaps here. So this top one and this middle one. These nasal concha do all sorts of things for the upper respiratory system. They warm, swirl, and moisten incoming air. They're covered with mucus-lined soft tissue, so mucosal tissue. The inferior nasal concha is just part of it's a separate bone itself. That's why we only labeled superior and middle under the ethmoid. Sutural bones are not even barely worth mentioning, but I'm going to, just so you know what they are. These are found within sutures. They're tiny bones found within sutures, those immovable joints. So sometimes when you see a suture running along on the top of a skull, you'll see this little tiny pebble of a bone like this, and then the suture will continue. That's what a sutural bone is. These vary in number from person to person, and they're not considered in the count of the 206 bones in the human body. Now let's do some facial bones. That concludes all of the cranial bones. I'll get through as many as I can here. I'll go in the order of your book. First is the mandible. That's the lower jaw, what you and this is the largest and strongest of all the facial bones. So that's its first claim to fame. It's also the only movable bone of the skull. Spell that correctly. It's also the largest and strongest. I'll just give you some fun facts and some features of it. The mandibular angle just refers to the side of this. Let me draw a decent picture for you. So here's the mandibular condyle that articulates with the temporal bone. This would be the right side if this is a lateral view of what the mandible looks like. Here's the area with the teeth. So I'll just start labeling these giant teeth, these molars here. And if it wrapped around this way, there'd be more teeth over here, the surface of the teeth, and another set on the far side of us. The features worth mentioning, this word ramus, U-S, R-A-M-U-S, just refers to the flat side of the mandible right here, that you can feel the side of your lower jaw. It's a flat bar-like piece of bone on both sides. The mandibular condyle, we've already identified. A condyle is a process projection that specifically articulates with another bone. In this case, now you know that the mandibular condyles articulate with the fossa in the temporal bone to create that temporomandibular joint. Also worth noting, just some language of the mandible. The alveolar process just refers to this whole jutting forward part of the bone that the teeth are inserted in. There's two holes, one on this side of the midline and one over on this side, right and left, that are called the mental foramen. So there's a hole that the mental nerve goes through. So there's two of those. They're just located on either side of the midline of that mandible. There's also a foramen worth noting back on the inside of the mandible on both sides. So the one that we could see would be right here that I'm drawing. I'll exaggerate it. And there's also one down on the inside of this side. That's called the mandibular foramen or foramen. And if you've ever had any dental work done, those nerves that run through those two foramen are where dentists specifically go for anesthesia, to anesthetize that part of your mouth. This pointy process here is called the coronoid process. And it creates this valley called the mandibular notch. These are all areas for musculature attachment. Let's go to the maxilla. This is what you and I would call the upper jaw. And the reason I put an E at the end of this is because it's plural. There's actually two bones that are fused together, right and left. And they make up the upper jaw. They fuse prior to birth. So in the event that that fusion is not complete or doesn't take place prior to birth, that's when the person is born with a condition called a cleft palate, because there's a cleft or space between those two bones of the maxilla, the right and left sides of the maxilla. That can present problems like infection, difficulty with speech. It's typically surgically corrected very early in life and very successful if done early enough in life. So I'm looking at a quick list I made of maxilla features, and I'm just going to list the most important one. This bone also has paranasal sinuses in it. I haven't talked a lot about sinuses yet. I will right now, just so in case I don't get to it. A sinus is an air cavity, an air chamber that's lined with mucosal tissue. That means fluid secreting mucus. They are air-filled chambers that they're really not even present at birth. When they form, typically 2 times during childhood when they start to form, and that is when we first form our teeth and the teeth break through in the mouth, and then later during puberty, toward the end of puberty, they start to form as well. These sinuses in general, all sinuses, they're found in the frontal bone, the sphenoid bone, the maxilla. All sinuses in general, what they do is they allow for expansion of the bone, growth of the bone, without causing the skull to weigh anymore. So they lighten the weight of the skull as it grows. They also resonate sound when we speak. The resonance of sound. If you plug your ears and talk out loud, you can still hear yourself in your head. What you're hearing is the resonance of sound that your voice is making through those sinuses, and they define a lot of what the pitch is of our individual voice. And you know what happens if these sinuses fill up with fluid and the air chambers can't resonate, like when you have a cold or an allergy, your voice sounds different, not only inside of your head, but to other people as well. They also increase the surface area of the mucus. An inflammation of this tissue is called sinusitis. And that can be caused by an infection. It can be caused by injury. It can be caused by an allergy. We've all had sinusitis, inflammation of this area, and we get fluid accumulation in there as well. Last thing on the maxilla I'm going to mention are the infraorbital fissures. So in those eye sockets that we drew earlier, they're called orbitals, we have that X. They look like almost like cracks or crevices in the rear of the orbits. The infraorbital fissures are part of the maxilla. The supraorbital fissures are part of the sphenoid bone. And there are also infraorbital foramen as well. Just inferior to these eye sockets on the front of the skull, in the maxilla bone, are 2 small holes. Those are for cranial nerves facial nerves to pass through, and they're called the infraorbital foramen. Doesn't look like I'm going to get quite as far as I wanted to today, guys. I'm going to give you a break. I wanted to get to the vertebral column, but I'll quickly go through zygomatic bones, nasal bones, lacrimal bones, vomer next time, and there's almost nothing to say about them other than where they are located in the skull. I did talk about paranasal sinuses, so I won't need to do that. And then most of our discussion will be the back half of chapter 7 on Thursday. Let me cut off my recording.